Hello, everyone. Welcome to the United States Geological Survey Public Lecture Series. Thank you for joining us tonight for our lecture this month. My name is Christy Ryan, and I will be your host and moderator today. Before I introduce our speaker, I just want to make a few announcements and allow some folks out there to get settled and logged in. First, I want to give you a heads up about our lecture for next month. On September 22nd, we will have the pleasure of welcoming Robert DeGroot with our Earthquake Hazards Program, just in time for National Preparedness Month, which is observed every September. And the title of Robert's talk will be Shake Alert, Earthquake Early Warning for All. So please be sure to join us next month as well. At the end of the lecture, I will provide information on how to be part of our mailing list, so you'll always be in the know on upcoming lectures and the topics. Next, we want to take a minute to give you some tips on how to use a few features of this live Teams platform. If you're watching from a desktop computer and need to turn on closed captions, just go ahead and look at the bottom right-hand corner of your screen for the closed caption icon. It's the one with the 2 C's. You can also now use stream text to view live closed captions, and I went ahead and put a link in the Q&A chat window, so you can open that link in a new tab and get the live captions. As for the Q&A feature, that's the question and answer panel, which can be opened by clicking the question mark icon in the upper right-hand corner of your screen. At the end of the lecture, we will open it up for a Q&A session, and this is where you're going to submit your questions. So please feel free to do so all throughout the lecture, and we'll go ahead and ask the speaker at the end. We're going to do our best to get to all the questions, but sometimes we get so many we don't have time for all of them, so we'll do our very best, but appreciate your understanding about that. So now let's go ahead and begin our talk for tonight. We have the pleasure of welcoming Dave Solar. Dave has been a research geologist at the USGS since the early 1980s. Beginning as a laboratory assistant and driller, he led several mapping and map applications projects before becoming chief of the National Geologic Map Database. Dave has guided this important activity since its beginning in 1994. The National Geologic Map Database is a congressionally mandated initiative by the USGS and Association of American State Geologists, which represents the nation's state geological surveys. This state-federal partnership has ensured the long-term success of the National Geologic Map Database, and Dave enthusiastically notes the many contributions made by state partners. Dave is also Associate Program Coordinator for the USGS National Cooperative Geologic Mapping Program. So without any further ado, let's all give a warm virtual welcome to Dave. Dave, the floor is all yours.
Thank you. Thank you and good evening. I'm very pleased to be given time to tell you about something about geologic maps and reports in general and how to find them. To give you a bit more understanding of who I am and my priorities, my research mapping and public service career focused on making regional and national map compilations and applications of geologic information to societal issues such as earthquake hazards and groundwater contamination. Prior to joining the U.S. Geological Survey, I worked for an oil company in the Gulf of Mexico and for an engineering consulting company. I picked up what I know about computer programming and computer-aided mapping along the way, beginning in the early 1980s. So let's get started on tonight's subject, which is all about geologic maps. First, let me activate the pointer. Okay. So as population expanded in this country in the 1800s, state and federal initiatives were begun to survey the landscape largely for economic potential such as minerals and coal, and to find groundwater. At the federal level, there were 4 geological surveys conducted before the U.S. Geological Survey was established in 1879. The map on the screen is one of the maps from the Hayden survey published in, I think, 1877. And
Dave, sorry, we don't actually see your screen.
Oh my goodness.
We're missing all this good stuff.
Yeah, well, you know, missed a vital step, which was to share my screen. I was thinking about what I was going to say. All right, let's go back. Sorry about that, folks. So what you're looking at is, again, is this map from the Hayden Survey, 1877. I wanted to thank former Colorado State geologist Vince Matthews for finding these maps, purchasing them, and getting them scanned. So this is showing, again, Western Colorado and part of Utah. These geological surveys that preceded USGS were the central product was the geologic map, and these led to the creation of the US Geological Survey. So what is a geologic map, for those of you who don't know? Well, fundamentally, it shows the characteristics and distribution of the many types of earth materials beneath our feet and to some depth into the subsurface. If you've ever looked at geologic maps, then you know that they each seems a bit different in layout and how the map features are described. They're unlike road maps or topographic maps, for example, which have pretty much the same look and feel from one map to another. For example, here are two recently released topographic maps, USGS maps, which lie side by side in north central Arkansas. These are from the USGS's standard series of topo maps at 1 to 24,000 scale, which means 1 inch on the map is about 0.4 miles on the ground. These maps look very similar in layout and symbols, as they should. They're a standard product from coast to coast. Now, geologic and topographic maps have a very long and close link. Even before the USGS was established, for example, in the Hayden Survey, the map I just showed, geologists and topographic mappers work together in the field making maps. If you don't have a good topo map, you really can't make a good geologic map. Now, I picked these two maps because earlier this week, one of our partner agencies, the Arkansas Geological Survey, notified us of two newly published maps that were funded by the USGS National Cooperative Geologic Mapping Program's state map component, which partially funds mapping by the state geological surveys. Every year, the USGS and the state surveys publish hundreds of geologic maps and reports, and you can find them all through the National Geologic Map Database, which I'll refer to as NGMDB from here on. And I'll show you how to do that a bit later in the hour. So here are the same two quads, but showing the geologic maps side by side. As you can see, there's much more to a geologic map. Extensive explanation of map units and line symbols, diagrams showing how the many geologic map units relate to one another in terms of their age of formation. In many cases, geologic maps are among many sheets that accompany a book report on the geology of an area. So here's a closer look at the map that was on the left, the Batesville quad. There's the map itself. There's the so-called description of map units. It describes some information about each map unit. There's a diagram that shows how it might look in a road cut, this stratigraphic column. There's a cross section. And this little bluish diagram here shows the orientation of joints in the rocks, which can be very important for understanding faulting and groundwater movement. I want to zoom in on this little diagram here on the right. On the left side is part of the description of map units, which I mentioned earlier. And on the right, these little black dots, they indicate where information on earth materials was collected. This is a really important point. That is, geologic maps are interpretations of what can be seen in outcrop and boreholes. It's like having a few pieces of a jigsaw puzzle and making an informed decision or informed interpretation of the whole picture. And as we get more information over the decades, our interpretations of geology improve, and so new maps are made of the same area. Modern technology such as LiDAR can help us make better maps, but tramping the landscape in search of outcrops and drilling test holes is the essential part of it. Now, some maps cover the entire nation or several states and show a simplified view of the geology. Again, this is the Hayden map that I showed earlier. This map 100 years later, western part of Colorado, this is the state map of Colorado, shows a very similar picture, but more detail in the map. I'll just toggle back and forth real quickly. You can kind of see the valley running through here, which is here. So more detail, newer map. Yet older maps remain very useful, in part because they may show features such as mines that don't exist today, but also because the essential processes of gathering, organizing, and presenting geologic maps have remained stable over time. And that's because in the late 1800s and the early 1900s, geologists came together to agree on a set of standard science and map-making concepts and terms that we follow to this day. And so I generally show this slide. The standards in the USGS were guided by our second director, John Wesley Powell, and the goal, I think a laudable goal, was as he stated here, to try to make the information more standard and predictable and understandable to non-geologists. As I noted a minute ago, the two maps I just showed cover broad areas and so must show a simplified view of the geology. But because most uses for geologic maps are at a local scale, such as the house lot, towns, and counties, many agencies have been mapping at a detailed scale. Our database's catalog includes tens of thousands of those maps. Here's a view of some of the maps in the Denver area. Denver's over here. The Front Range of the Rockies lies along here. So why do they all look so different? Well, it's because detailed geologic mapping is an expensive undertaking that's done by many federal, state, and other agencies for different purposes. These purposes have varied with time and with economic and global events, and include the need to find new energy, mineral, and water resources, and also concerns for mitigation of natural hazards, such as earthquakes, volcanoes, and landslides, and also for finding and protecting groundwater supplies. In some cases, such as the search for strategic minerals during wartime, and very importantly today, mapping focuses on areas of mineral potential, whereas in other cases, such as local concerns about land use, the focus is in urban and developing areas. So I've noted that geologic maps are useful, so let me give a few examples. But before I do, I'd like to note that of the 108,000, you're looking at the catalog's search page, 108,000 citations in it. More than 41,000 has specific information about energy, mineral, and water resources, and about 13,000 focus on earthquake, volcanic, and landslide hazards. Those reports were funded by many agencies so that the nation's private and public sectors would have geoscience information needed to support informed decision making. So when seeking to explain how geologic maps are useful, I turn to publications like this one. You can't read the title probably, but it says Interpreting Geologic Maps for Engineering Purposes. I recommend reading the introduction. It's just excellent. So generally, we think that everything's online, but what I wanted to do, I don't know if you can see this, but this is the actual copy of it. This comes from a series of maps called the Geologic Atlas of the U.S. folios, published from the 1800s to the mid 1900s. And so many of the products that we need to access are only available in paper, or they're best available in paper, and we're working hard to get them online. But many times what you see online is not quite good enough, and so we're continually going back and improving the scans and so forth. Anyway, I digress. So the authors took a geologic map, and that's one of the entries shown here, and they presented the information in different ways to help people address issues such as digging a foundation, where to get suitable rock for construction, where to find a water supply, and how rocks affect decisions on siting a road or a dam. As I said, the explanation for this report is quite good, and that's listed here in this introduction page. So here's the geologic map. It was part of the Geologic Atlas folios, and they have a history that I could spend an hour talking about. They're quite fabulous maps. This map series began, as I said, in the late 1800s, and many of the map standards developed for use in this, commonly agreed upon between the states and the USGS, they're still in use today. So what you're looking at here are folded rocks in the Appalachian Mountains in Pennsylvania. So they're not only high quality, they're quite good to look at. So this is a piece of the geologic map presented so that information about foundation and excavation conditions are highlighted. This says excellent foundations, difficult excavation, requires blasting and power tools for removal, strong, durable, well-drained foundation. So what they did is take the geologic map, they rated them for properties of, slope stability and foundation, and that's one of the so-called derivative maps that you can make, or we can make from a geologic map. Now, when geologists retire, sometimes in the building here, they leave books on the giveaway table. A few years ago, we noticed someone had left a large book on military geology of the Truk Islands. Again, I don't know if you can see this, but this is a large book, so-called gray literature, hard to find any copies anywhere. We did it. That report has 262 pages and 50 maps in it. Doing some investigation, we learned that it was part of a set of reports of the Pacific Islands prepared by USGS for the Corps of Engineers to plan military operations during World War II in the Pacific. So we tracked down 26 of these island reports from various sources, scanned all the text and maps, and they're on the site for you to see. The science, the USGS science and the map making are high quality, and they clearly illustrate the importance of the geology, the earth materials, not only for military purposes, but also for infrastructure development. This is the map of Guam, very similar in components to the map of Arkansas I showed you. The map, the description of map units. Here are some cross sections up at the top, some line symbols, and so forth. So in a minute, I'm going to show you this area right in here. So you're looking at the geology of the east part of the island of Guam. That area was interpreted for suitability for cross-country movement. So, passable, impassable in dry weather and wet weather, predominating slopes, that sort of a thing. So that was accompanied by a suitability for amphibious landings. So again, very serious applications for geology. If we were to turn to the issue of domestic issue of groundwater vulnerability and potential for contamination, here's a geologic map that shows the vertical stack of materials to a depth of 20 feet. So each of those little map areas on there is labeled with a code that indicates the downward sequence of materials in that upper 20 feet. So why would they do this? Seems unusual, perhaps, to us. Well, one application of that so-called stack unit map is shown here. It provides guidance on where to site a landfill. This type of map is sometimes referred to as a stoplight map, red, green, red, yellow, green. In this case, red indicates areas where permeable material, rock, is through which the water can flow is present in those upper 20 feet. The green areas indicate impermeable material in the upper 20 feet, which might represent a good place for considering siting a landfill. Years ago, I worked with the authors of that report on a 3D modeling project of aquifers in the glaciated terrain of east central Illinois. Buried at some depth is the Muhammad Aquifer. It happens to show right in here at this layer. It's a very valuable regional source of groundwater. The results of this study helped to establish a regional private-public consortium to improve understanding of the Muhammad Aquifer and to coordinate on its use. Now, this map sheet shows the many layers of glacial deposits of different glacial advances that lie above bedrock, which is down here. On the left is the 3D view of that layer. In this case, well, let's take the next one down. This is a very recent glaciation. This is the elevation of that surface, and this is the thickness of that unit. So you can see as you come down here, the Muhammad is this yellow in this bedrock valley. Here it is flowing from basically east to west. This is the another sheet from that publication. It shows several cross sections through the area, so we can all get a better understanding of the distribution of deposits, especially the Mahomet. These cross sections, these east-west, they're running along here, of course, and these ones seemingly turned up on end are running north to south across here. Here's a close-up of that page. Those cross sections have been arranged in what's called a fence diagram, so you can see them all together and get kind of almost a three-dimensional sense of the distribution. This is another way in which geologists try to represent what's going on in the subsurface. This is called a slice map or process, where you're looking at land surface and then you're slicing everything below an elevation of 775 feet and then 750 and so forth and so on. As you gradually slice your way down, you're seeing these high areas of the older glacial deposits exposed. You keep going down and you start seeing that Mahomet aquifer. So it's just another way of conveying the information, helping people to visualize it, understand it better so they can make better decisions based upon it. Now, regarding different types of geologic maps, I've just shown you a few of the more unusual examples. By searching the NGMDB catalog, you'll find thousands of the more familiar types of geologic maps, such as those showing mineral deposits. In addition to geologic maps, there are many other types of geoscience maps and reports that are useful. As shown in the previous slides, geologists often map the elevation and thickness of buried geologic units to understand the water resources, and also for things, to look for high places in certain rock units that can serve as traps for oil and gas. The lines on this map, you can see them in here. These lines show the elevation of the top of the water table in the Dakota sandstone. That's a very widespread porous unit that in this area is an important aquifer. This map is from the Pueblo Atlas Folio, published in 1897. So maps showing the contours or thickness of individual geologic units are extremely valuable. They help us visualize the extent and configuration of units in the subsurface, which in turn helps us build 3D models that more visually convey that information to decision makers. And so more than a half dozen USGS scientists are working with me to examine the more than 60,000 maps, charts, and other large format sheets that are viewable through the NGMDB. The goal is to tag each of the 60,000 plus images with the type of geologic information that it shows. You probably can't see this, but these are the tags that run through here: geologic map, cross-section, geochronologic information, soils maps, water resources, petroleum, coal, that sort of thing. So here you can see that I tagged this particular image with the name of the geologic unit, depth to highest water-bearing bed of the Dakota sandstone. The reason we do that is so that this information will become searchable. You'll be able to, pose the search, find me all contour maps of the Dakota. This is one of the enhancements to the NGMDB that will be released in coming months and years. Having quick access to all, for example, contour maps of the Dakota surface and its thickness will enable geologists and of all types to make more detailed maps, 3D models, and so forth. Now, as I mentioned, this map was originally published. It was published in 1897. And the author, a very famous geologist, G.K. Gilbert, he wanted to help people visualize what this unit's top surface looks like. So he photographed a plaster model of the Dakota top surface. Very innovative, and it uses really the same concepts that we use today when we do computer modeling of buried surfaces. Thought you might be interested in this. It's the explanation, and it says this is a view from the above of the flexed and faulted Dakota. as it would appear if restored whenever it had been removed by erosion or laid bare where it was covered by other formations. Again, it's a plaster model. And the thing that I find very fun, to give the proper effect, the sheet should be so placed that the light from window or lamp falls on it from the right. And so he placed a little ball so you could visualize that the light was coming from the upper right, falling across the Dakota surface. So again, 1897, thought it was a really interesting way of getting the point across. Another type of non-geologic map that's extremely useful to geologic studies. This is a chart of many types of geologic information that was recorded for a test well to evaluate oil and gas potential along the US East Coast continental shelf. Zooming in a little bit, these are the downhole geophysical logs that are routinely run in a borehole. From that and from the well cuttings, you can put together a stratigraphic column, which is shown here. And also to the right here, we've got the relative proportion in that interval of sand, shale, carbonate, evaporite percentage. And this is the measured porosity. You're looking for high porosity deposits in which oil and gas could be trapped. This is another one. This is very interesting. It's a complex 3D portrayal of many carefully measured sections in a coal-rich area in Wyoming. Each of these columns shows the geologic units and the fossils that were found, which help pin down the age of the unit. In this close-up, you can see the level of detail and the correlations between sections across the coal field. The complex diagrams such as this are most commonly used by experts, especially in private industry. The map I showed earlier, the so-called stoplight map, that is geared towards decision makers who need to use the geologic information to make land use decisions. This is really, again, for experts, especially, as I said, especially in private industry and the oil industry. Give one last example. This is a geologic map of the Las Vegas area, published fairly recently. Just wanted to show you in this close-up, just relating it to the previous few slides. These are geologic sections. They're helpful to geologists for understanding how the rocks and their distribution changes across this Las Vegas quad in areas that have undergone different faulting history. These are different thrust plates, different faulting sections across the map area. Now, because that area of Nevada has long had important mineral reserves, to better characterize the 3D geometry of the rock units, maps of the gravity and magnetics were made, which used that previous the geologic map for reference. So, gravity will tell you whether it's extremely light or dense. It kind of gives you a sense for the geometry of the buried units. Magnetics, similarly. Concern about availability of rare earth elements and other strategic minerals has recently prompted a large increase in geologic and geophysical studies such as AeroMag to re-examine in more detail the areas of mineral potential. So in closing, I'd like to show you how to find these maps and reports in the NGMDB and briefly acquaint you with the website's other resources. But first, I need to explain to you what the NGMDB is, how it came to be in just a couple slides. It originated in the Geologic Mapping Act of 1992, which formed the partnership between the state geological surveys and the USGS, formed the National Cooperative Geologic Mapping Program. The purpose of the act, as stated, is to expedite production of the Geologic Map Database, so that this NGMDB has a central role for USGS and the state surveys in terms of geologic mapping. One key part of that legislation was a stipulation that for standardization. I mentioned the standardization that occurred in the late 1800s as geologic maps were just beginning to be made. the standardization in the digital world, you might say, we're essentially bringing forward standards that have been in use in the, on paper maps into the digital environment. And so we're working together to make digital standards so that the information can be, brought into various database systems, but also used by, by every private citizen. I want to acknowledge the many members of the that I work with on the project, some of whom have been with this project for more than 15 years, and in some cases nearly 25. So the folks in the top row are essentially full-time with us, and they're all all part of the team. Definitely part of the team, and including many collaborators in other parts of the USGS and also definitely in the States. So I'd like to do walk the high wire and try the web here and go through a quick introduction of these topics: standards, the geologic names lexicon, TopoView, catalog, and map view. And to find the site, just in your web browser, you can just search for NGMDB. So let's see. All right. Minimize that. Okay. So the first thing I'd like to do is acquaint you with the homepage. The various resources are listed top and bottom, kind of a duplication, which is good. I'd like to first start out with standards. We'll get the so-called dry stuff out of the way first. Now, if you go to standards, you just happen to find something called progress reports in here. Interesting. There we go. So just to learn a little bit more, just a paragraph or two about each part of this project, you can come to the task summaries. There's even a little slideshow here that describes geologic map coverage over the decades. What I wanted to do is to go to the standards page itself. And again, many of you may not really be, this isn't something you're going to use, but I think it's important to be aware that the standards are being developed and that they're benefiting us all by making the information more understandable and easier to use. So two main standards here. One is for cartography. This is a Federal Geographic Data Committee standard for symbolizing geologic maps. We have very careful stipulations on line symbols, for example, faults, the specifications, when to use them, what they should look like. Things such as lithologic patterns, how you show these rock units and sediment units in a stratigraphic column. And we even have various paleontologic symbols that can be used in those correlation charts or those stratigraphic columns that I showed. So that's the cartography. That's the way in which the information is displayed. In terms of the way in which the data are held in a file, well, we produce PDFs or paper copies of geologic maps, but we also provide for use in what are called Geographic Information System software, GIS software. We're producing standardized file formats for geologic maps, and it's the so-called GEMS standard. So let's so this is really we're really proud of this achievement that all the surveys have worked together, and just over the last couple of years we've started producing in volume geologic map databases in the GEM schema, which will be then pulled into the NGMDB, made into a master set of database files and available for your use. But let's just talk about the maps themselves now. when you look at a map, many times you'll see units. I mentioned the Dakota. Here I'm going to search for a unit called the Ogallala. Well, that was interesting. Well, we seem to have a little glitch in the system. I will pop back to that in a minute. Let's take a look at TopoView. If you come into TopoView, you go to Get Maps. So this is a quick way to find topographic maps of the nation. What I'm going to do is just, sometimes if I know the zip code, I'll just search by the zip code. So this is the zip code in which I am sitting at the moment, right in this area in Northern Virginia. I'm going to look at a map published in, let's say, 1915. Oh, darn it. Whoops. Didn't mean to do that. Meant to do this. So this is what this area looked like in 1915. You can use transparency and see what it looks like today. This is a very popular interface for all kinds of uses, from archaeology to genealogy. Now, you see this Dulles Toll Road running through here. When this was built, you see this land was still, my building was not here and it was still undeveloped. You come a couple years later, and it's pretty well built out. So TopoView is a really quick way of finding information, downloading the maps. The files come in several different formats. If you want to print one of these maps, we recommend the GeoTIFF format. It's rectified so that it's all set up and sized for a paper print. So let me just real quickly, I'm not sure, I've just got a few minutes left here. I go to the catalog. So when you want to find something in the catalog, it's best to enter as little information as possible, like not the full title, but let's say just a word or two. So if I were to enter Batesville, I come up with 13. Well, 13 is a pretty good number. I could look for, I could look through that list. If I want to only look for publications in which I can see an image, then I'll go to this includes map preview. And I get 7. I'll go to that list. Now, it's always sorted by scale. You can sort it by year, by publisher and series. I'm going to sort by year. And I'm going to pick this map. And this is the map I showed earlier. So you can zoom in. You can come down here and get the publication. This is an Arkansas survey publication, not USGS, so we route users to the agency that published the map. If you like what you found, let me show you one trick here. Those Corps of Engineers maps, and we can provide URLs for these, but the Corps of Engineers maps are under other government agencies. U.S. Army Corps, there it is. 26. So you can share the link. So this link will always bring you back to this page. You want to refine the search, you simply click here and maybe from that set, you want to find the maps of Guam. So it's a pretty straightforward system. We will be accompanying that. We will have a footprint-based option for this. Instead of just text search, we'll be providing one that'll enable you to do searches similar to this this map view. I don't know if you've seen this. I have zoomed into the San Francisco Bay Area. So the way this works is we have cached geologic map images that are of 24,000 scale into image caches, so they display very quickly. These are the maps at 1 to 48,000, 1 to 62.5, and so forth and so on. The all layer is a non-cached version. It's a little slower, but it shows all the maps with the most detailed maps showing on top. There is kind of a nice feature here. This little thing down at the bottom, it says reference on. When you click that off, then you can see things that are offshore that we're not clipping to the coastline, for example. So if I zoom, these are the 24,000 scale maps. If I click reference on, what you're seeing are some maps offshore. It's a set of maps by USGS offshore. If you click on any map anywhere, you will see over on this side, you will see that map. And you'll also see other maps in the area that are not in map view, but if I were to click on this one, I could go to it and see it. So map view offers ways to, to see the map that is currently being shown, but also to get to other maps in that area. You can search by title, this list by title, by year, so I can show just the oldest maps, that sort of thing. So it's a very powerful way of kind of getting the lay of the land, seeing what's available, seeing what is available in terms of geologic maps. We will be, as I mentioned, expanding the catalog search to show geologic maps as well as the rest of the 108,000 publications, so that you'll be able to find those more easily on a place-based search rather than a text-based search. The only disappointment I had, oh, there we go. Okay. Well, that is so odd. This does not do justice to the geologic names lexicon. I am not sure what the problem is. The geologic names lexicon shows for 16,000 formal geologic names in the US. It shows the, I really would like to get to it. It shows the origin of each geologic name and the information about it, the scanned cards that we have from the Geologic Names Committee. So I apologize to Nancy Stam for for the fact that it did not work tonight. It is part of the entire system, so why it was not functioning is beyond me. It's probably something I have done. I have one more idea. All right, so if at first you don't succeed, just try another browser. All right, so what I did is I searched for the name Ogallala, which is a widespread aquifer geologic unit in the mid-continent, and it comes up with this. You click here, and it'll show the name, the subunits that lie as part of the Ogallala group or the Ogallala formation, the age, the type section, where it was best and first described, and then links to significant publications. So this is going back to the map catalog. This is NH Darton's report from annual report 19. The next one is again another one from the folio, Darton's folio. So these link back to the catalog. This is an interesting button here. We scanned the 220,000 index cards from the Geologic Names Committee going back to the last century. Well, actually the century before that. And this is the sort of information you find in here. The origin of the name, publications in which it was named. So this information goes into the record that we saw a minute ago here, where these are the significant publications. So anyway, I was glad I was able to show that. I think it's time for me to wind this down. I thank everyone for their time, and let's throw it open to any questions.
Awesome. Thank you so much, Dave. That was a great talk. Just hearing all the history and especially seeing all the examples and the demo, which, as we all know, when you're trying to demo something, especially live, things never quite go the way you want. But I think for the most part, we really got the gist of the power of that database, and just having everything there is pretty amazing. So we've had quite a few questions coming through, and just a reminder, you guys are welcome to submit questions. There's that Q&A panel, which is the question mark icon. Looks like many of you have already found it, so please keep them coming, and I'll post a note in there when we're ending the Q&A session. So let's go with the first one here from Anonymous. Let's go up. Will this website only have geologic maps for area within the United States?
It's a very good question. Under the congressional mandate, yes, it is for the United States. However, the U.S. Geological Survey does make maps of other countries. There are some very notable ones. We also make planetary maps. So we are considering how to include other planetary body geologic maps in NGMDB. Given enough time and resources, we'd like to consider at least the maps made by the U.S. Geological Survey of other countries. But anyway, the answer is not yet.
Okay. The next one we have here, this person anonymous says, on the main NGMDB site, there's a globe icon with a geologic map. Is that showing the entire world or just North America? And is it available online?
Yes. So this is the geologic map of North America published by the Geological Society of America. And it's just been essentially wrapped around a cue ball, and it shows this is Hudson Bay. This is Hudson Bay here, the United States, lower 48 here. So I can show you how to find that right now. So let's go to the catalog. Now, this is where you can put in way too many terms. So I'm going to put in North America, and I happen to know one of the authors, it's Chris Garrity. So I'll pick that one, and there are two. So what you're seeing here is that there are two. Oh, this is the tapestry of time. Let's look at this map first. So we released the database for the printed geologic map of North America as a USGS product, and you can see it here. You can download copies of it, but we also have a supporting site, which is shown here, which lets you grab the pieces again, get more information about it, look at the documentation. So just simply going to the page, where the heck did it go? Right, just simply going to this page, you'll be able to find the resources under external resources or download a copy of the map itself. Christy, are we going to provide URLs to some of these?
Yeah, I can certainly do that.
Okay, I did give you the URLs to some of the major the slides in the PowerPoint. Maybe we could add this to it.
Sure.
Okay.
Great. Okay, so another one here. And this is kind of a two-parter. So this person asked a question and then somebody did post a follow-up. So I'm gonna read the question and then I'm gonna read what somebody here wrote and then we'll get your input as well. The question is, how does the USGS decide which areas get a geologic map? Can I request one for my area or would I have to hire someone? And then would it be included in the database? And we do have a viewer, Ben Fisher, who wrote in, and again, you know, Dave will send this to you after. The USGS doesn't normally decide where geologic maps are created. We are typically contracted by cooperators, which would be towns, counties, states, other federal agencies, to create geologic maps for a specific purpose, like aquifer mapping for water quality purposes and many other purposes depending on a cooperator's needs. So that was an answer Ben Fisher gave, so we'll throw it to you.
Yes, in the U.S. Geological Survey, there are many programs that are funded by Congress: energy program, minerals program, earthquake hazards, landslide hazards, volcano hazards, coastal and marine mapping is done, and the National Cooperative Geologic Mapping Program. And each of them they respond to the needs of their program. So they conduct studies of all kinds and geologic mapping as needed for, you know, areas of concern. They may be told by Congress to map a particular volcano after an eruption, that sort of a thing. The state geological surveys, which there are partners in this project and also in the Cooperative Geologic Mapping Program, they are guided by a state mapping advisory committee to determine the priority areas for mapping. And as was noted by the other response, there's also a great deal of mapping done in response to cooperator requests and cooperator funding. It could be a county, for example, that funds a state geological survey or USGS to do some mapping.
Okay, great. Melissa asked, will the older ArcInfo files be re-released as more usable GIS files?
I like that question. The answer is yes. This project is mandated by Congress to be a national archive. So a responsibility of a national archive is to keep, not lose, but continue to migrate forward the information in the archive. And that's one of the reasons for that GEM standard. It's not just a standard so that you can view it in a GIS, but it's a standard so that we can convert old ArcInfo files to GEMs and then mass migrate all the GEMS files to a new standard or to revision of the standard later on. So we're trying to stabilize the situation, not lose previously published ArcInfo and all kinds of other old GIS formats. And we're just beginning that process.
Okay, great. Somebody commented, beautiful maps.
They are.
Another question, is there a way to download a bunch of quadrangles at once for an area of interest via TopoView?
What we ask you to do is to send that request in, and we forward it to the National Map Help Group, which can address bulk downloads. The TopoView interface was designed for a quick view, a comparison of maps of different age, and a quick download in those file formats. So we create the various file formats. We're over, I think, 4 to 5 million individual files now in TopoView. But TopoView is just designed for single. The group in USGS that makes the topographic maps, the National Geospatial Program, would handle bulk downloads.
Okay. I'll reply to this person too with their email address for TNM help.
Yes.
Another one, from where can we access shapefile of the US?
So if it's of the US, I could point to the Geologic Map of North America, which is the most current map of the United States, North America, but the United States. So I would suggest coming here and going to the supplementary GIS files and getting it there. Always, if it's a USGS product, if you don't find what you need, you think it exists, you can always come to the comment form. So we have a corrections form on every web page, and you can send in a question or a comment, but you can also, well, I got so many tabs open here. You can also come up here to our comment form and just simply pose a question. You know, do you have shape files for the Geologic Map of North America? That sort of thing.
Great. Another question, how often do geologic maps get updated?
It depends. In some maps are explicitly titled as preliminary geologic map. Therefore, the plan is probably to version it and produce a more formal geologic map soon thereafter. But in other cases, many years or many years could go by before there's the funding and the priority given to that area to remap it. So it really all depends on local issues. Local issues generally, I think, drive it.
Okay, makes sense. Another one here from Anonymous. Can you show us geological, in parentheses, rocks and soils, historical and recent maps?
Historical and recent maps. Well, I'm not quite sure what exactly the person's looking for. You can look in MapView for, see if I can do this. You probably can't see it too well, but on the left side, if I were to zoom into an area, the list changes. I'm looking in this region, the Bay Area, and you see a list of maps that are available, and you can sort it by year. So the one at the top is the oldest. I flip it around, and now you're looking at a 2019 map. So I'm not exactly sure what you're asking, but MapView is a way to just explore what's available. Now, not all geologic maps are in there. This is definitely a work in progress, as is the entire project. So we're gradually adding not only new maps, but we're working backward in time to add old maps to MapView. And that's why you'll find over on the left side, you see something that says in view. That means it's in MapView, but many of the others do not say in view, and they're either haven't been scanned or they're not georeferenced and put into MapView. Sorry, I was just kind of guessing what the answer needed to be.
Yeah. Okay, just a lot of comments, great presentation, very impressive. Jim asked, is there a YouTube tutorial for NGMDB?
No, we have an arrangement with the the Geological Institute to do webinars. We've done one webinar on stratigraphic nomenclature, and in our tiny little world, you might see it's gone viral. So Randy Orndorff did that one. It was extremely popular. We have planned to do one with AGI on how to navigate the NGMDB. I'm hoping that despite that perhaps this will be somewhat of an introduction to the services, but yeah, we need to do a polished YouTube. Well, when I say YouTube, it would be done by it'll be done by USGS or AGI, and can be available on YouTube.
Okay. Another comment. This is from Paul. Great presentation. Can't wait to try it. Thank you. Another viewer out there, Mitch, he asks, do all maps have a viewable or, more importantly, printable image in database?
Right. So let's just take a quick look at that. If I look for, let's say, just bedrock maps, there are 35,000 that have a bedrock map. The ones we have viewable, you come down and you click on this includes map preview. When I do that, it drops to 20,800. So about what, 2/3 of the maps have a scan or a PDF of them. So we're working very closely with the USGS library and the publications warehouse to develop the entire set of USGS maps and reports as as high quality scans. So there are partners. I would like to note that the catalog is the fundamental part of this project, and it began in close cooperation with our library system. So we're there, but we're very much appreciative for what they do. Very appreciative.
A couple more here that came in, Dave. Yeah. From Nancy. Is there work on incorporating map data into virtual reality scenarios as a way of visualizing Earth materials? I've always thought geologic data an ideal and challenging application of VR.
I'm sure there are. I've seen a little bit myself, but I can't point to one right now. But any way that we can get the information out to to various venues is applauded. I'm keeping myself in this project in the role of content providers, so we're taking responsibility for organizing and trying to provide the best information for people to do virtual reality studies. But I'm not closely in touch with them.
Okay, this one from Anonymous. Will the National Geologic Map ever be interactive as lines and shapes in a browser? Modern tech allows us to review and interact with data without downloading it. Is there a future for geologic maps to be available in this way?
Yes. So we have the project was always characterized in 3 phases. Phase 1 was find all the information you can, organize it, make it available. That's the catalog and the lexicon. The second phase was try to organize it, standardize it. Phase 2. Phase 3 was, okay, when you've organized and standardized the information, you bring it into an enterprise system, as was just described. We prototyped that several times. The latest was in 2009. We didn't carry it forward because we were waiting. The community had to come together with enough basically a standard, which is GEMS. So we now have GEMS. We are amassing enough information in GEMS to deploy an enterprise, vector system, so that you'll be able to see initially individual maps, but then eventually what's known as a seamless map of the nation. So there's a large initiative in the mapping program to do just that, to take the information that's provided by NGMDB, that's poured into the system, and to stitch together an increasingly gapless and seamless map of the nation. But these things do take time. You know, you can prototype them, but until you have a critical mass of data to really warrant deploying it to the public, you just need to wait.
Sure.
And I think we're almost there.
Great. This one from Ben Fisher. Are there any interesting prototypes coming in the future?
Well, there's the enterprise system that I just mentioned. There is a significant update to MapView, which will, I guess I could show it right now. Well, no, I won't. Mobile friendly, you know, kind of like a fly through, kind of like Google Earth. So there's that. And then what we've been calling internally Map Explorer, which is a footprint-based. Let's go to here. It's kind of a footprint-based system. So if you're in here, you'd be looking at footprints of geologic maps or all types of products in the catalog. Click on it and, you know, find information about it. So we think that's going to be a really powerful way of perusing the database, the 108,000 records, as a complement to a text search. But, you know, fundamentally, as I mentioned before, we focus so strongly on the content, like behind the scenes, tagging the content of 60,000 images is our priority, whereas other projects are, you know, their priority is interpreting the information, making new maps.
Okay, just a few more here, Dave. These are just really good questions. I hate to not ask them.
Sure, go ahead.
Yeah, this one from Anonymous. Has NGMDB looked into rendering 3D models using browser-based 3D visualization rather than on a 2D piece of paper? Such tech is readily available and does not require a user to install a plugin.
Yeah, let me see if I can find the file. I don't know if this answers your question or not, but did I just lose the share? No. Okay. So this is the next release of MapView. So the idea is to link it in with formation level information, allow fly-throughs like this, make it mobile friendly. The current build of MapView is a few years old, and so it's kind of in line to be upgraded. You know, I view those things as relatively easy to do. I'm not strictly a fan of prototypes that have little data. What a national project like mine feels responsibility for is to just continue to improve the content, and when there's enough content, then roll out an application that takes advantage of that. But I and the members of the project would welcome any suggestions anyone has for types of products, types of access to this information that you'd like to see. We answer every question that comes in on this comment form, and we'd really like to hear from you.
Awesome. One of the viewers, Jen McLean, said great presentation, wonderful resource. Thank you, Dave. Someone, Anonymous, says if NGMDB is a national archive or library, Does it have a partner or component for modernizing the technologies it uses to visualize data for users?
Could you repeat the question? Does it have what?
Yeah. Does it have a partner or component for modernizing the technologies it uses to visualize data for users?
Well, yeah. Several members of the project are largely responsible for that. So they're looking out for the new technologies while I focus on the content mostly. That probably wasn't a very good answer. It's 10:11 p.m. here, and
I know.
and you can see the quality of my responses may be tailing off here, but
no.
You know, this project, as I said, does focus on content, but we have a very keen eye out for improving the technology for presenting it, and I'm very proud of the people on the project who are doing just that, especially the folks responsible for MapView and TopoView. And again, there's not only the interface, but there's an awful lot of back-end work that has to be done to make a system like that work with the increasing IT restrictions that a major government installation has. So.
Okay, just two more if you're up for it. How do states send USGS their map data? Do they upload to a map service?
They get a secure login, and they can enter the citation into an input form and enter the GEMS data through through a different form. In the past, it's gone through a long history. When, before PDFs were invented, we just had citation pages, and then we gradually started developing an image library of maps that we would scan, and then the states were increasingly making PDFs and emailing them to me or sending them on a hard drive, and we're now at the point of establishing a WAF, web accessible folders, for the states to upload the PDFs and the GEMS files, which we then ingest and show on the pages. The next step is, as I said, collecting those GEMS files into an enterprise system so that they can be queried as a mass of data and not individual GEMS files.
Great. And the last question, what is the USGS's priority for geologic mapping right now?
USGS. Well, the USGS again is many funding programs, earthquake, volcanoes, minerals, hazards, that sort of thing. If I were speaking for just my program, the National Cooperative Geologic Mapping Program, we have many priorities. We have priorities of 24,000 scale bedrock and superficial mapping of high priority areas, urban and developing areas, and then a priority to develop a national scale map of intermediate scale mapping for the entire nation that is tied together in a GIS. So we're trying to manage and address many needs at the same time.
Okay, well, that was amazing, and we got through quite a few questions here. I can't thank you enough. I'm sure all of our viewers want to give you a huge thank you as well, Dave, for taking the time, giving us the demo. We really appreciate it. I know I've been here over 20 years. I learned a lot from what you talked about tonight. So yeah, huge thank you to you.
Thank you very much for allowing me to do this, and I appreciate the questions. And again, I really appreciate your interest in technology that would move the content forward in new ways. So please stay in touch. Yes,
absolutely. And not just a thank you to Dave, a thank you to everyone out there for joining us, especially with our new time of 6 p.m. Pacific to help accommodate others across the country to make it more manageable. In case you do want to watch this lecture again or share it with others, Dave's lecture will be available in about a week for on-demand viewing on our website, which is www.usgs.gov. www.usgs.gov/PLS. On that website, you'll also find videos of our past lectures. We've been doing this for over 30 years, so we have quite a collection on there on all various topics. You'll also find our lecture schedule for the remainder of this year, and pretty soon we're going to start adding our schedule for next year, so be sure to check that out. If you want to be added to our mailing list, so you'll always receive these notices, please send us an email. You can reach us at wmcesic@usgs.gov, and we can easily add you to our list. And finally, we hope you will join us next month, September 22nd at 6 p.m. Pacific time, for Robert DeGroot's talk on Shake Alert, which will be very interesting, earthquake early warning for all. So until then, thank you again, everyone, for joining us. Thank you, Dave. Everyone have a good evening. Good night.
Thank you.
Thanks.